Okay, so we all know about magnets, right? Like sticking stuff on the fridge.
Hmm.
Or, you know how the Earth has a magnetic field, and that's how compasses work? Magnetism's like everywhere, really.
Right.
But what if I told you there's like a whole other level of magnetism that we're just starting to get a handle on?
Yeah, we're not talking about the kind of magnets you stick on your fridge here.
Right.
It's way more than that.
Exactly.
Yeah.
And that's what we're going to be diving into today. These are called subtle magnetic fields, or SMFs for short.
And these aren't your typical bar magnetism either.
No, no, no.
We're talking about fields that could be messing with things on a huge scale, like how galaxies form,
Wow.
but then also on a super tiny scale, like atoms.
So it's kind of like all over the place, really, these subtle magnetic fields.
Yeah.
And for this deep dive, we're looking at this documentary script about SMFs, trying to figure out what they are and how they're different from the magnetism we already know about. And get this, the script calls them hidden tuners of reality.
Yeah, that's a pretty bold statement.
It is, right.
But think about it this way. Imagine SMFs like the dial on a radio.
Okay, I can see that.
They could be subtly tweaking the frequency of everything, matter and energy, and that could totally change how galaxies rotate, how atoms behave, all sorts of things.
So are these SMFs like breaking the rules of the magnetism we learned in school? What about Maxwell's equations? Don't those explain pretty much everything about electromagnetism?
Well, yeah, Maxwell's equations are super important. They show how electricity and magnetism work together and how they make those electromagnetic waves that we use for, well, almost everything these days. Like, think about it. Radio, Wi-Fi, it's all electromagnetic waves.
It really is.
But the thing is, with SMS, there might be even more to it.
Like what?
So in physics, magnetic fields, the regular kind, come from electric charges when they're moving.
Makes sense.
Like no moving charges, no magnetic field.
You need a source for the field.
Exactly. But with SMFs, there might be other sources we haven't found yet. Think of it like there's this magnetic stuff out there, but our instruments can't see it.
Wow.
And this stuff could be making these SMFs. Yeah.
Okay, so there could be this whole world of magnetic activity that we're just starting to peek into. But hold on, it gets even crazier. This script says that SMFs might not even be stuck in the 3 dimensions we live in.
You got it.
It's like 3D is not enough for them.
Right.
We're going beyond that now.
Exactly. The SMF theory suggests that these fields could be hanging out in fractional dimensions, or maybe like extra hidden layers. The script calls them fractal expansions.
Okay, I'm trying to picture this. Help me out here. What's a good way to visualize these fractal expansions? I know the script mentions a 3D fractal structure.
Have you ever seen like a Menger sponge?
I don't think so.
It's this cube with holes in it, but then those holes have holes and so on. It's like it keeps going forever.
Oh, wow.
That kind of gives you an idea of how SMFs could exist in this crazy complex way, not just the simple 3D we're used to.
So it's not like the nice lines of force we see around a bar magnet. These SMFs are like weaving through hidden dimensions or these fractal spaces?
Yeah, something like that.
Wild.
It is. And it all connects to this thing called the Fibonacci scale, which says that the universe is like a ladder with different levels. You've got the huge cosmic scale and then down to the super tiny atom level.
Yeah, I remember us talking about that before. Like, different physics might be at play at those different levels, right?
Right. And with the SMF theory, these fields can adapt to each rung of the ladder. So
Yeah.
they can affect things at those crazy different sizes.
So one field could be messing with both galaxies and atoms.
Exactly.
Okay, now that blows my mind. But is there any proof of this? What makes scientists even think these SMFs might actually exist?
There are some cool clues out there.
Oh, really?
Yeah, and the script points to two main things.
Okay.
First is how galaxies rotate.
Okay, so what's strange about how galaxies spin?
So when astronomers look at how fast stars are moving in a galaxy, a lot of times it seems like they're moving way too fast.
Too fast.
Yeah, like faster than they should be based on how much stuff we can see in the galaxy.
So, like, not enough visible matter to create enough gravity.
Exactly.
So that's where dark matter comes in, right?
Yeah, that's one idea. That there's this halo of invisible dark matter surrounding galaxies, and that's providing the extra gravity. But the SMF theory, well, that suggests that these subtle magnetic fields could also be part of it.
Oh, interesting.
Yeah, like they could be acting as a kind of scaffold, helping hold the galaxy together and affecting its rotation.
So instead of dark matter, or maybe working with dark matter, you've got these SMFs potentially holding galaxies together.
Yeah, it's a pretty wild concept.
It is. What's the other piece of evidence?
Okay, so this one's from the world of atoms.
Okay.
Scientists have noticed these tiny shifts in the frequencies of atoms,
Okay.
and they can't quite explain these shifts with normal physics.
So the atoms are vibrating at like a slightly different rate than they should be.
Yeah. And the SMF theory, well, it suggests that these subtle magnetic fields could be causing it.
Oh, I see. So remember how we were talking about SMFs being like a cosmic radio dial?
Right?
It's like they're tweaking the frequencies of atoms a tiny bit?
Yeah, exactly.
Wow, so we're talking about a possible link between giant galaxies and tiny atoms, all connected by these SMFs.
It's a pretty big idea, right?
It is.
And the script even goes into how these SMF frequency shifts might actually work. There's an equation for it, but the point is that even super small changes in the SMF could make a big difference in how atoms act.
Hmm. So like a butterfly flapping its wings and causing a hurricane. Okay. A small change leading to a huge effect.
Exactly.
Okay, so we've got SMFs maybe affecting galaxy rotation and maybe messing with atoms too. But how does this all tie in with that relative vacuum of space theory, or RVS, that we talked about in a previous deep dive? I know the script brings those two ideas together.
Oh, yeah, that connection is really important because it gets to how SMFs might actually make a force that works like gravity.
Okay.
So remember, the RVS theory says that the vacuum of space isn't really empty. It's filled with this scalar vacuum wave.
Right, like a hidden energy field everywhere.
Exactly. And the script has this equation suggesting that when SMFs and this RVS wave interact, they create a push force. And that push force, the theory says, is what we feel as gravity.
Hold on. You're saying that gravity might not be a fundamental force, but something that comes from these interacting fields.
Yeah, it's a pretty radical idea.
It is.
But it shows how this combined SMF-RVS thing could potentially explain the large-scale universe and those tiny atoms all at once.
Wow. So it could unify the cosmic and the quantum like we never thought possible.
Yeah.
Okay, let's say for argument's sake that SMFs are real. How would scientists actually prove they exist? Where do they even start looking for something so subtle?
Yeah, it'd be tough, but the script lays out some good ideas for how to do it.
Okay, like what?
One way is astronomical surveys.
You know, using those massive telescopes to look for huge magnetic fields out in space that don't act the way we expect, like beyond what the normal processes in stars and galaxies should be making.
So looking for magnetic weirdness in space.
Yeah, stuff that could be from SMS.
Oh, okay, that's cool. What else?
Another way is lab spectroscopy.
Ah, with the atoms.
Right. Scientists can use really precise instruments to measure those tiny, tiny frequency shifts in atoms.
Okay, yeah.
And if those shifts match what the SMF theory predicts, that would be pretty strong evidence.
Right, right.
Yeah.
So we've got astronomers looking way out in space and physicists looking super close at atoms. What about computer simulations? Could those help too?
Totally. We have computers now that can simulate like whole galaxies and tiny atoms in amazing detail. So scientists could add SMFs to those simulations and see if they match what we see in the real world.
So like, can SMFs explain why galaxies are stable even though we don't see enough matter?
Exactly. Or can SMFs accurately predict those frequency shifts in atoms? Ah, I see. So they're using simulations to basically test the SMF theory.
Yeah, that's the idea.
And if the simulations match reality, that would be big news.
Definitely. And if all this research from like telescopes and labs and computers all start pointing towards SMFs, well, it would completely change how we understand the universe.
Yeah, it's wild to think about. It's like we might be on the edge of discovering this whole new layer of reality.
Yeah.
This hidden world of magnetism controlling everything. The script ends with this beautiful image of the universe as a giant organ. And the SMFs are like these unseen notes that create harmony between galaxies and atoms.
Yeah, it's a great analogy.
It really is. It connects those huge cosmic things with the smallest building blocks of matter and says that maybe they're all linked by these SMFs.
It really makes you think, what else might be out there influencing the universe in ways we haven't even imagined yet?
Yeah, it makes you realize just how much we still don't know.
That's the coolest part of science. There's always more to learn and more mysteries to solve. And maybe someday, with all the brilliant scientists working on this, we'll finally be able to hear the whole cosmic symphony. Thanks for joining us on this deep dive. We hope you learned something new and that it left you curious about the universe and all its mysteries.